13.7 billion years ago, the universe was a fraction of a millimeter in diameter. That's smaller than this dot. But the universe has grown since then. Matter of fact, it's still growing. But how do we know that? Well, in 1929, American astronomer Edwin Hubble had been studying the light emitted from multiple galaxies. When he compared the visible light spectrum of the different galaxies, he noticed that the light of the further galaxies was not what he expected it to be. Instead, he noticed that the observed spectra had been redshifted.
What's a redshift?
Good question. When an object is moving away from Earth, the wavelength of its light is stretched, which causes it to shift towards the red end of the spectrum, causing the redshift. A redshift also indicates how fast the object is moving away, so the larger the redshift, the faster it's moving. Hubble noticed that the further away a galaxy was, the more redshifted its light was, which meant that it was moving away faster. This indicated a proportional relationship between the recessional velocity of a distant galaxy and its distance, also known as Hubble's law. By graphing this, Hubble realized that this was a linear relationship and the Hubble constant was determined, a number that tells us how fast the universe is expanding. The Hubble constant can be multiplied by the distance to find the recessional velocity of a distant galaxy. In the 1990s, a group of scientists were studying the brightness and redshift of Type 1a supernovae when they noticed that the supernovae were too faint to be consistent with the theory that the universe was expanding at a constant rate. Instead, the data implied that the expansion of the universe had been accelerating over the past 5 billion years. Then the question became, how? And the answer is dark energy. Dark energy makes up about 70% of the known universe, but we cannot detect it. What we do know is that it's a form of energy that some consider an evil counterpart to gravity, or as I like to call it, an anti-hero. Instead of pulling things together like gravity, dark energy stretches the fabric of space-time and drives cosmic objects apart at an increasingly rapid rate. But while dark energy is a very powerful force, it only seems to act on the largest scale of the universe. In places like galaxies that have a lot of matter, gravity overpowers dark energy and holds them together and keeps matter from flying apart. I guess the universe is a firm believer of the saying, there's always room for growth.